Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for HCF and LCM. In this session, we are going to discuss some applications of HCF and LCM. Along with that, we are going to take some problems related to numbers, divisibility concepts, and some basic algebraic formulae and their applications. Okay. Now, I would just like to advise you that do attend the 3 previous sessions before attending this particular session. Okay. Because some of the concepts will be directly using from these 3 sessions. Okay. Definitely you'll be having a paper and pen with you, so you'll be solving the problems with me. So at the end of the session, you'll find yourself more comfortable with HCF and LCM. Okay, so let's begin this session. Now let's take the first problem. The rectangular floor of dimensions 3 meters 60 centimeters, here it must be centimeters, and 5 meter 40 centimeter is to be covered with identical square tiles. Find the minimum number of square tiles required. Okay, that means the dimensions are 360 centimeters and 540 centimeters. We wish to find out the number of square tiles. First of all, we have to find out the size of that particular tile. Okay, that size will be actually HCF of 360 and 540. Okay, so HCF will be we are having a zeros over here, but definitely HCF will be multiple of 10, then 36 and 54. HCF of these two will be 9 into 2, that is 18. Okay, so HCF of 360 and 540 is 180. That means that size or the length of square tile must be 180 centimeter. Now we have to find out the number of tiles. That means number of tiles is equal to area of the floor, that is 360 into 540 divided by area of tile. Now length of tile is 180, that means area will be 180 into 180. Okay, so it's 18.2 and 18.3, so that is 6. So 6 square tiles are required to cover up that particular area. Okay friends, I hope you are clear with the concept. Now let's say this problem. 4 runners start running simultaneously from a point on a circular track and take 400 seconds, 300 seconds, 200 seconds and 150 seconds respectively to complete one revolution. How long will they take to meet at the starting point? Then suppose these 4 persons are maybe A, B, C and D. Okay, they are starting from one particular point and they have to meet at the same point once again. Okay, now A is taking 400 seconds to complete one revolution. That means after every 400 seconds he'll be reaching to this particular point, suppose X. Okay, so he'll be coming at this position after 400 seconds, then 800, 1200, 1600, 2000 and 2400 and so on. Similarly, B, after every 300 seconds he'll be reaching to this position, so 300, then 600, 900, 1200, 1500, 1800 and so on. Okay, similarly C is coming after every 200 seconds, so it is 200, 400, 600, 800, 1000, 1200 and so on. Similarly, D will come after every 150 seconds. So it's 150, 300, 450, 600, 750, then 900, then 1050, then 1200. Okay, now you'll observe after every 1200 seconds A, B, C and D, all of them are reaching at the same position. Okay, that means they'll be meeting once again at the starting point. Now what this 1200 is? this 1200 is actually LCM of 400, 300, 200 and 150. Okay, just take LCM of 400, 300, 200 and 150. It is actually 1200 seconds, that is 20 minutes. It's very simple, friends. I just explained you through this diagram that how it is happening. Okay, else in your examinations you don't have to draw the diagrams or the table, you just can take the LCM of the datas and you can get the answer easily. Okay, let's do the next problem. Now let's see this problem. There are 3 cakes weighing 210 grams, 540 grams and 720 grams respectively. Find the minimum number of pieces into which these cakes can be cut such that all the pieces have equal weight. Okay, that means we are asked with the minimum number. That means we have to find out the maximum weight. And it will be nothing but the HCF of these three datas. Now, what is the HCF of 210, 540 and 720? That is 10 into 21, 54 and 72 will have HCF as 3. So the HCF of these three datas are 30. That means the maximum weight over here will be 30 gram. Now we have to find how many number of pieces will be there. Okay, so 210 by 30 in 200 gram, 7 pieces of 30 gram will be there. Similarly in 540, 18 pieces will be there of 30 grams, and in 720, 24 pieces will be there of 30 grams. So in all 24 plus 7 plus 18, that is 49 pieces will be there of 30 grams. Okay friends, as simple as that. Now see this problem. The signboard at the clothes store Smart Clothes Showroom lights up as described below. When the switch is turned on, all the three words light up and remain lighted for 3 seconds. After that, the first word goes off for 5 by 6 seconds. The second word for 1 by 3 seconds and the third word for 2 by 3 seconds. Each word follows its respective pattern of lighting up for 3 seconds and going off for its respective duration. How many seconds after the signboard is switched on will the entire board remain lighted for 3 seconds for the second time? That means every light is coming and it's there for 3 seconds, then it is going off for a respective duration. Okay, this is for first light, it is this, then for second and for third. That means we have to find out the LCM of 7 5 by 6 plus 3, because it is coming after the first light is coming after every 7 5 by 6 seconds and it is there for 3 seconds. Okay, so we have to find out the LCM of 7 5 by 6 plus 3, 1 1 by 3 plus 3 and 3 2 by 3 plus 3. Okay, let's see. Okay, we have to find out the LCM of 7 5 by 6 plus 3, then 1 1 by 3 plus 3, then 3 2 by 3 plus 3. So it's actually 65 by 6 and 13 by 3 and 20 by 3. So we have to find out the LCM of these three fractions. Now what is LCM of fractions? That is LCM of numerators by HCF of denominators. So we have to find out the LCM of 65, 13 and 20. What that will be? It is 13 into 5, it is 13, it is 4 into 5. So it is 13 into 5 into 4. Okay. And HCF will be 6, 3, 3. HCF will be 3. Okay. So it is 260 by 3, which will be 86 2 by 3 seconds. Okay. As simple as that. So the answer is 86 2 by 3 seconds. That means after every 86 2 by 3 seconds, these lights will glow simultaneously. Okay friends, I hope you are clear with the method. Now let's see this problem. We have to find out the remainder when this expression is divided by 80. it seems to be an application of algebraic formula. It's of a cube plus b cube. Here 17 plus 23 is making 40, as well as 19 and 21 is making 40. So let's rearrange it. 17 cube plus 23 cube plus 19 cube plus 21 cube. Okay, so it's 17 plus 23, that is a plus b, a square plus b square minus ab. Okay, plus it's 19 plus 21, here a square plus b square minus ab. Okay, now 17 plus 23 is actually 40, so 40 can be taken as common from both of these expressions. Now we see this 17 square will generate an odd number, plus this will also generate an odd number. Okay, so odd plus odd is even. Now that even minus this odd will be odd number. Okay, so from this expression we are getting an odd number. Similarly, here it will generate an odd number, it will also generate an odd number, so odd plus odd is even, and minus this 19 into 21, it will generate odd number, so even minus odd will be getting odd number. Now odd plus odd will be getting an even number, that means at least it will be 2, so 2 into 40, that is 80. That means this expression is actually multiple of 80, so it won't give any remainder except 0. Okay, as simple as that, and it is a good application of algebraic concepts or algebraic formula. I hope you are clear with the method. Now let's see this question. Monu has a certain number, that is less than 1000 of chocolates with him. If he distributes them equally among a group of 12 or 15 or 18 children, he would be left with one chocolate in each case. If he distributes the chocolate equally among 19 children, he would be left with no chocolates. How many chocolates does he have? Okay, that means our answer should be multiple of 19, as well as if that answer is divided by 12 or 15 or 18, it should leave the remainder as 1. Okay, now let's go by elimination of option. That would be much easier for us to do. Suppose the correct answer is 50. Now if I divide 50 by 12, I'll be getting the remainder as 2, since 48 is multiple of 12, so it cannot be the right choice. Okay, similarly I check the option, that is 181. Okay, it 12, it is divided by 12 or 15 or 18, it will leave the remainder as 1, since 180 is multiple of all of them. But now let's see whether 181 is divisible by 19 or not. Okay, it's not divisible by 19, since 19 9s are 171 and 19 10s are 190. So even it cannot be the right choice. Now we are left with two options, that is 551 and 361. Now let's see 551 is divisible by 19 or not. Suppose I divide it by 19, I'll be getting 19 2s are 38, then 171, that is 19 9s are. Okay, so 551 is divisible by 19, so 551 can be right choice. Now let's see whether it fulfills the other conditions or not. Suppose I divide 551 by 12, what is the remainder I would get? Just let's calculate. Suppose I divide it by 12. 12 4s are 48. I'm left with 7 and 1. So the remainder is minus 1, that is 11. So it doesn't fulfill the condition. Now we are left with 361 only. Obviously it will be right choice, since there is none of these. Then also we just check it out. 361 is actually 19 square, then definitely it will be multiple of 19. Now 360, we have to see whether it is divisible by 12, 15 or 18 or not. Okay, so definitely 12 30s are 360. Similarly it is divisible by 15 and 18. Okay, so 361 will be the right choice. Now let's see this question. When a three-digit number divides 67588 and 63424, it leaves the same remainder in both cases. Find the least possible value of the three-digit number. That means we have to find out the difference between these two numbers, that is 67588 minus 63424. So what will be getting? 8 minus 4, 4, 8 minus 2, 6, 5 minus 4, 1, and 7 minus 3, 4. So 4164 or any other factor of 4164 when divide 67588 and 63424, it will leave the same remainder in each case. But we have been asked about a three-digit number, but 4164 is a four-digit number. That means we have to choose a number which is factor of 4164. So out of the options, we just have to select the correct number, which is factor of 4164. So let's see whether 101 is factor of 4164 or not. Suppose 101 is multiplied by 40, that is, it will give 4040, and 4040 and 4164, 101 cannot be factor. Similarly 231, if we divide 4164 by 231, we won't be getting an integral value. Now let's check by 347. It is 3470. Now we are left with 4164 minus 3470, that is 6, 9 and 4. Now let's see 694 is multiple of 347 or not. Yes, 347 into 2 is 694. That means this number 347 is factor of 4164, hence it will be the correct choice. Okay friends, I hope you are clear. Friends, 347 into 12 is actually 4164, that I have shown you the calculation over here. 347 into 10 plus 347 into 2, that comes to 694. Okay, let's see the next problem. Now let's see this problem. When 5, 8 and 12 divide a multiple of 13, they leave remainders of 3, 6 and 10 respectively. Find the least such number. Let's go by options. Suppose I divide this number, that is 169 by 5, it should leave the remainder as 3. Okay, but it leaves the remainder as 4, so it cannot be the correct choice. Now similarly it cannot leave the remainder as 3, so obviously it is also eliminated. Now we have to check these two options. Okay, if 598 fulfills all the conditions, that means it will be the correct choice. We need not go for 1298 since we have been asked about least such number. Now 598, if divided by 5, it leaves the remainder as 3. Now let's divide it by 8. And in that case it should leave the remainder as 6. That means 592 must be multiple of 8. So it's 8 sevens are 56, 3 2, 8 fours are 32. That means it is multiple of 8. That is 592 is multiple of 8. That means it is also clear. Now if it is divided by 12, it should leave the remainder as 10. That means 588 should be divided by 12. Okay, so it's 12 fours are 48, 108, 12 nines are 108. That means it fulfills all the conditions, hence it is the correct choice. We don't have to check 1298. Okay, now let's see this question. Ina, Meena and Dika went to Meena's aunt's house. Her aunt offered them some dates. Ina took 1/4 of the dates but returned one because she had a momentary pang of guilt. Meena then took 1/5 of what was left. Friends, let's do this problem by elimination of options. Since there is a long story for this particular question, let's do it by backward approach. Suppose 36 is the correct choice. Okay. Now, Ina took 1/4 of the dates. Okay. So that means she took 9. That is 36 by 4. She took 9. but she returned 1 because she had a momentary pang of guilt. That means she had only 8. Okay, that means we are left with 36 minus 8, that is 28. Okay, so here we are having 28. Now Meena took 1/5 of what was left. Now we are left with 28 and Meena is taking 1/5. So 1/5 of 28 will be a fraction. So it cannot be the right choice. That means 36 cannot be the right choice. Now let's take 44. Suppose 44 is the correct option. That means Ina is taking 11 and then she's returning 1. That means finally she is taking 10. Okay, so we are left with Ina is taking 10. We are left with 34. Now the second one is taking 1/5. Further 1/5 of 34 will be a fraction. So even 44 is not a correct choice. Okay. Now let's assume the number to be 32. So Ina took 1/4, that is 8. Then she returned 1, that means finally she is having 7. Now 32 minus 7, here we are left with 25. Okay. Now Meena is taking 1/5 of what was left. So 1/5 she is taking, that means 20. Here we are left with 20. But her aunt forced her to take more, 2 more. So finally she is taking 22. I'm sorry, she's having 1/5, that means 1/5 of 25 is 5, then plus 2, that means 7 she is taking. Okay, now we are left with 25 minus 7, that is 18. Okay, now here we start with 18. Dika then took half of the remainder but threw 2 into the ball. That means she is taking half of that, that is 9 she is taking. Then further she is throwing 2 into the ball. That means actually she is taking 7. So that this girl is taking 7. So we are left with 18 minus 7, that is 11. That Mina's aunt took the remaining 11 dates. Okay, so it matches with the given calculation. So 32 is the correct choice. Okay, so whenever you are given the long stories, you should go by option. That is the best approach. Okay, don't try to make any sort of equations. Okay, friends. In this question, there are a certain number of soldiers in a field. If the soldiers are arranged in a rows of 8 or 15 or 20, one soldier is left out. If the soldiers are arranged in rows of 9 and 13, 4 soldiers only are left out. Find the number of soldiers in the field. Friends, definitely we have to find out a number which is multiple of 8, 15 and 20. Then we have to add 1 to that. Okay, so it will be really a lengthy process. Let's go by option. Let's see if 109 is divided by any of them, that is 8, 15 and 20. Does it leave the remainder as 1 or not? Okay, so if 109 is divided by 8, it doesn't leave the remainder as 1, since the last number which is multiple of 8 is 104. That means it will leave a remainder of 5. Okay, so it cannot be the right choice. Similarly, let's see for 113. The last multiple of 8 is 112. That means it leaves a remainder of 1. Now let's see it for 15. 15 sevens are 105. So it leaves 105. That means it leaves a remainder as 8. So even it cannot be the right choice. Okay, now let's see for 117. 117 is 13 nines are 117, but we have been told that if it is divided by 13, the remainder should be 4. So even it can't be the right choice. Now we are left with 121. Obviously it will be right choice since we have not been given none of these over here. Then also just check for the sake of clarity. Okay, so if 121 is divided by 9, just see whether it leaves a remainder 4 or not. So 13 into 9 is 117. Okay, so if it is divided by either 13 or 9, it will leave the remainder as 4. From 8, definitely 120 is last multiple of 8. below 121, so it will leave the remainder as 1. Similarly for 15 and 20, so definitely 121 will be the correct choice. I hope you are clear. Now let's see this question. Four bells toll simultaneously at 10 a.m. If they toll at intervals of 5 minutes, 10 minutes, 15 minutes and 20 minutes respectively, at what time will they toll together the next time? That means the first bell is ringing after every 5 minutes, the second is after every 10 minutes, and the third is after every 15 minutes, and fourth is after every 20 minutes. That means we have to find out the LCM of 5, 10, 15 and 20. Now what will be the LCM of 5, 10, 15 and 20? Definitely it will be 60. So they'll be ringing together, or they will toll together after 60 minutes. Okay. So after 60 minutes after 10 a.m. will be 11 a.m. It's very simple but very commonly asked question in entrance examinations. Okay friends. Now let's see this problem. There are 30 mango trees, 40 guava trees and 50 apple trees. The trees are planted in such a way that each row of trees contains trees of the same variety. It's trees. And every row contains an equal number of trees. Find the minimum number of rows in which all the trees could be planted. Since we have to find out the minimum number of rows, that means we have to plant maximum number of trees in a single row. Now one more condition is that each row should contain equal number of trees. Okay. That means precisely we have to find out the HCF of 30, 40 and 50. Definitely it will be 10. Okay. Now suppose I wish to plant mango trees. I'll be in requirement of 30 by 10. That means 3 rows. For guava trees, I'll be in requirement of 40 by 10. That is 4 rows. And for apple trees, I'll be in requirement of 50 by 10. That is 5. So in all, I'll be in requirement of 5 plus 4 plus 3. That is 12 rows. Okay friends, it's very simple. So it's the correct choice. Now this problem, there are 4 prime numbers written in ascending order. The product of first 3 prime numbers is 2431 and that of the last 3 is 4199. Let's go by options. Suppose 17 is the correct choice, then 17 is the greatest number. That means the other numbers are 13, 11 and 7. Okay. Now 13 into 11 into 7 is actually 1001. And here we require 2431, so it cannot be the right choice. Now suppose 19 is the correct choice, that means the other numbers are 17 into 11 into 17, 13 and 11. Let's see, 17 into 13 into 11 will produce 17 into 11 is 187 into 13. Okay, 13 sevens are 91. 13 8s are 104, 104 plus 9, 13, 3, 13 and 11 is 24. So 2431. So this is the correct choice. Okay friends. We should not go for any sort of cross verification for other 3 numbers, that is 13, 17 and 19. We just can match the unit digit, that is 3 into 7, 1 into 9, 9, which matches over here. Okay, since no other combination can produce these numbers, that is 2431 and 4199. Okay, so I hope you have learned a lot in this session. We'll be discussing more such problems in our coming sessions. Okay, bye bye and all the best.